All right, so we're going to jump into part 2 of this, graphing tangent and cotangent. And here we have a cotangent equation. So we're going to go ahead and solve this, graph this. I don't know why I said solve. So pretty similar process, not all that different. We're going to take what is inside of the trig function, cotangent in this case. We're going to use that to solve for some asymptotes. The values we use are different for cotangent. For cotangent, we're going to take this, we're going to set it equal to 0 and to pi to find our two asymptotes. So here is our first equation here. We got 2x plus 2 pi equals 0. That'll be our first one. And then 2x plus 2 pi equals pi. And then we'll be able to solve for our two asymptote places. Again, this is different. We're using different values here than for tangent. Tangent, we use negative pi over 2 and positive pi over 2. Here we're using these. That's because we're talking about a different function. They have different asymptote locations. Okay, let's go ahead and solve this. These actually are a little bit easier without the fractions of pi involved. So let's subtract 2 pi on both sides. We end up with 2x equals negative 2 pi, and then we divide by 2. Divide by 2, we get x equals negative pi. So that's our first asymptote, negative pi. We'll make sure to plot that here in a moment. And then let's go ahead and solve this one. So we'll subtract 2 pi again. Okay. Again, that's going to be 2x equals, so 1 pi minus 2 pi is going to be negative pi. And then we will divide by 2, and we end up with x equals, well, negative pi divided by 2. And that's our second asymptote. So we'll go ahead and take that one, and we'll slide it over here. That's our second asymptote. Can kind of delete this work. So those are our two asymptotes. They're both on the negative side, so I guess that's why I have more graph over here. Unlike some of the previous ones, I'm going to need to do some scaling here. I kind of recommend just like using one of these default scalings because we're not going to make the tangent and cotangent equations all that confusing. But our farthest left one is going to be this negative pi, so let's just put that one over here. Pi over 2 is half of that, so half of that, negative pi over 2. So here's going to be our two asymptote locations, and our graph will sort of exist between them right here. Not ideal, still kind of scrunched, but sort of the best we can do with what we have. So I'm going to draw in my vertical asymptotes. Make sure they actually line up over these values. There we go. The next thing I need to do is make sure this scaling works and divide my period here, my cycle, into 4 even increments. So obviously this would be the middle of that. So that would be counting by pi over 4 increments. So this would be negative pi over 4. And then this would be negative 3 pi over 4. And then that's only 2 pieces. So I would need some sort of intermediate values in here, the middles of these. It's going to get kind of crowded to mark all of these out. So I'm actually not going to label what these are, but it is an even incrementing. I guess they're half of pi over 4, so they're pi over 8 increments. Yeah, we'll go ahead and work with this. We've split it up into 1, 2, 3, 4 even increments, and our scaling is nice and even. Again, just use kind of a basic Desmos graph if you're having trouble with this. You know, we could go back a couple, but like if we take a look at the scaling here, we could have used a scaling like this and kind of done it all in here. You can see the values already are written out for us, and just split that up. So use one of these sort of default scalings and kind of use the Desmos graph to help you come up with those if you need. Anyway, let's go ahead and move forward with this one. The next thing is to kind of think about the midline and amplitude and the 3 points that we'll need to graph these. So our midline is actually at 3. We can see that on the end of the equation, the plus 3. And our amplitude is 5. So we're going to be going 5 above that and 5 below it. So that means that we're going to need to go up to 8, which is 5 above the midline, and down to negative 2. So we need to scale that appropriately. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. 1, 2, 3, and then down to -2. So 1, 2, -2. That should be plenty of scaling. I want to give myself space above and below these because this graph is different than sine and cosine. It's just not going to bounce in between them. It's going to go, beyond these numbers. So it's fine to just use the scaling. I'm going to use guiding lines here for these just to make sure I plot them well, especially as I don't really have any sort of a grid to line stuff up with, like I've had in some of these previous problems. So these will just be my guiding lines for making those points. And now it's just a matter of graphing the 3 points. So this is a cotangent graph, right? So it's going to be generally decreasing and still kind of working out from the center. Our center point here is going to be on the midline in the center of the cycle. So here's our midline and here's the center of the cycle at -3π/4. So that's going to be where we start off with. And now this 1/4 point is going to be, we're going to go up the amplitude from that midline. So here's our 1/4 place right in here. We need to go up the amplitude, which we've already have this guiding line here for us right there. And then at the 3/4 point, we need to go down the amplitude. So here's our 3/4 line, and then we need to go down the amplitude, which again, we already have this guiding line for us. So we can put it on there. And now it's just a matter of kind of sketching in a nice smooth cotangent curve. Again, this wasn't reflected, so it is just a general cotangent curve where it is decreasing like this. All right, let's sketch it in. I'm going to try to do this and not miss all the points. Okay, that's not too bad. Not too bad. Hit all the points, kind of follow along the asymptotes. Even the scaling is not horrible. I was able to, yeah. All right, pretty satisfied with that graph. Again, this one was harder because we had to kind of come up with some of the scaling things, but hopefully it wasn't too difficult. We've already done very, very similar stuff to this in some previous units. And if you're having a lot of trouble with the scaling, go to Desmos and have that kind of create some of the scaling for you. It can be quite helpful. All right, let's move forward. If you want to try this one on your own, go ahead and feel free to pause it. Here's our equation. Take a second and pause it. I'm going to go ahead and jump straight into it. So first step, let's find the asymptotes. So we got to set that equal to 0 and to pi. So 1/4 x minus pi equals 0. 1/4 x minus pi equals pi. All right, so we got to multiply both sides by 4. That's not going to do anything really on this one. We're still going to get 0 because multiplying that by 4 doesn't do anything. And then add pi. And we get x equals pi. So that's one of my asymptotes. Similar idea over here. Multiply by 4. That is going to cancel that one out, and it's going to turn this into 4 pi. And then add pi to get there. And that actually is going to give us x equals 5 pi. So this one, this 1/4 has actually stretched our period out quite substantially. We're going from from pi to 5 pi. That's a pretty big stretch. That's not very standard scaling. That's actually going pretty far out to the right. It looks like I can just count in terms of pi though. So I can do 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, all the way out there and see what we can do from there. All right, let me move this over and erase some stuff. Okay. So again, I want to place these asymptotes in there. I'm just going to count by units of pi. So 1 pi, 2 pi, 3 pi. That way I hit both of these numbers, 5 pi and 5 pi. 4 pi, 5 pi. And this fraction has really stretched it out. We're going a little farther than we would normally go. Yeah. So let's draw in those asymptotes at pi and at 5 pi. So there's my asymptotes. We need to make sure this is split up into 4 even increments. So just kind of looking at it, here is the middle, 3 pi. And oh, here's the 1/4 that's already marked, and here's the 3/4. Okay, so it's 1, 2, 3, 4 even increments already. So that's great. That scaling works awesome. No need to really change anything up. just can go right there with what we did, counting by pi's. So awesome. Got that done. Next thing is amplitude and midline. I'm going to go same order that I did last time. So my midline is going to be up at 4, and my amplitude is 2. So midline is at 4, amplitude is 2. So we're going to have to go up to 6, right, adding those together, and down to 2. So 1, 2, 3, 4, 5, 6. 6 will be the highest, 2 will be the lowest, and then 1, 2, 3, 4 will be my midline. I like drawing these guiding lines in, especially when I don't have a nice grid to follow. Just sort of helps me line everything up well. It's not necessary. It can get confusing with a bunch of extra lines on here, but I think it works well. Now we are going into the point where we plot the 3 points for our graph. Keeping in mind we are doing a regular cotangent graph. It's not reflected. I like to kind of work my way from the middle. So in the middle, we are on midline in the middle of the cycle. So it's right here, middle of our cycle on the midline. Okay. And then at the 1/4, we need to go up the amplitude from the midline. So here's our 1/4 place at 2 pi. We need to go up the amplitude, which is 2 units. There we go. And then at the 3/4 mark, we need to go down the amplitude from the midline. So down 2. And again, we have our guiding line there to help us out. So those are the 3 points we need to kind of sketch in this cotangent curve. So I'll try to do this kind of piecemeal, make it look nice. And there we go. There's our graph. Again, super accuracy is not important. We're just looking for something that is representing a cycle of the graph visually for us. Yeah, that one was not too bad, actually. Pretty straightforward, honestly. All right, let me go ahead and clear this, and yeah, hopefully you got it right if you tried it on your own. Okay, so some general graph feature stuff that I've been mentioning, but I wanted to put down here and make sure I have a conversation about. When we think about where the graphs are and where we kind of start them, tangent kind of has a, just by default, is kind of centered along the y-axis. It has this point here in the center on x equals 0. And when we stretch the period out horizontally, or we scrunch it in horizontally by changing that b value, we actually kind of still keep that central location. It's still going to be centered. Now we can also shift the graph. We can move it left or right as well. But if we're just kind of affecting the period, we're kind of going to be, like an accordion, in and out from this point by changing the period. So if we double that period, it's just going to go stretch outward both ways from this. Or if we kind of shrink that period, it's going to shrink in both ways. So it also revolves around this central place here. Whereas on cotangent, the cycle kind of starts at 0, that leftmost asymptote. And it's only going to stretch or shrink away from that. So if we lengthen the period, it's going to stretch farther out to the right only. Or if we shrink that period, it's only going to shrink in towards that y-axis. It's not going to go both directions away from there. So a little bit of a different behavior as we change the period on that. In general, the graph is increasing for tangent unless we reflect it, right? Unless there's reflection. And the graph is decreasing for cotangent, again, unless it's reflected. The sort of default amplitude here is 1. That's the distance from the midline to these points, to these 1/4 and 3/4 points. That's our amplitude. So the bigger the amplitude, the more these are stretched upward. We could also have fractional amplitudes where we're kind of stretched downwards a little bit. Like if we had an amplitude of only 1/2, this point here would be much closer. It would only go to 0.5 here. And so that would kind of scrunch that graph in a little bit, and it would have a little more pronounced curve to it. You can sort of see how that would affect that graph there, having a fractional amplitude. And we could have even very, very small amplitudes that really accentuate it quite a bit. And then the midline, right? The midline always passes through that central point. So wherever that central point is, we got to be able to identify it and figure out, okay, that's our midline. Is it on the x-axis, or has it been shifted up or down from there, right? Because we can shift it up or down just by adding or subtracting onto the end. You'll notice here that we didn't spend much time talking about phase shifting at all. What we kind of incorporated the phase shift when we solve for the asymptotes. So we don't generally think about it, but these graphs can be shifted left or right. It's the same thing. When we have it, written in this format, this is still the phase shift. We're still shifting it from this kind of standard position somewhere else. It's just a little more complicated with these graphs rather than with sine and cosine. So we just kind of think about it a little differently. But there still is a phase shift that gets incorporated in this whole process. We just don't think about it in the same way. We find the asymptotes and kind of work from there. All right, let's go ahead and move forward. We're going to examine some graphs and just kind of make sure we can identify what transformations are going and mess around with maybe even coming up with the equation. All right, so let's go through this. Let's try to create an equation for this graph. So we're thinking about it for ourselves. Take a moment and just first think about, does this look like a tangent or a cotangent? And why would you think that? So take a second and think, and then I'll kind of give my answer. Feel free to pause it if you need some more time to think. I think this is a cotangent. Now, it could be done with tangent. Just like sine and cosine, you can actually write a tangent equation or a cotangent equation. You just have to, do some things, shift them and reflect them and whatnot. But I think of this as a cotangent for two reasons. One, it has that general decreasing trend, just like cotangent. Now, you could say, well, that could just be negative tangent. That would do the same thing. Fine, that's true. But there's another reason why I wouldn't necessarily use tangent here, and it has to do with the location of things. My asymptote being on that y-axis and moving out from there. So because of the location of the graph, where it's shifted left and right, that's another reason for me to not think about it as tangent, but instead to think about it as cotangent. Because of that asymptote being there on the y-axis, just like we saw in those previous graphs, that's going to lead me to a much easier cotangent equation rather than this reflected tangent equation that might be necessary. So we're going to think about it as tangent. Now, we may not go through these in the exact order that they are there. Can you identify the midline? Where is the midline of this graph? So feel free to pause it. I'm going to go ahead and answer it. So the midline happens at the middle of our period. So here's the middle of our period. Where's our graph? It's right there. That's the midline. It's happening there, down there at, what is that, -4. So this here is our midline, -4. What about amplitude? How much are we stretching up and away from that? Same idea, right? We need to find that distance that's going up and down from the midline, right? So here's our 1/4 location. Here's our 3/4 location. How far are we away from the midline? Well, here's our point, right? We can see it. This is our amplitude. We're 2 units away. Same thing on this side. We're 2 units away from the midline. That's our amplitude, 2. What about the period? We haven't talked a lot about period here, but we got to remember for tangent and cotangent, our default period is different than sine and cosine, secant and cosecant. It's actually going to be pi. So if our period is not pi, then we have a b value that's affecting it. There is an equation relationship, just like we learned before, that the period is actually equal to pi over b. This is similar to what we learned before, but because the default period is pi rather than 2 pi, it changes this part just a bit, right? It's not 2 pi, it's just pi. So there is a way to kind of figure out the b value from here. Well, what is our period? Well, here we're going from 0 to 2 pi. That's a pretty easy period to calculate. From 0 to 2 pi is actually just a period of 2 pi. Again, our standard period is pi, so it would be much more scrunched in by standing that. So it's been stretched out horizontally and that period has been changed. Well, don't we need the b value in order to calculate this? Yeah, we certainly do. if we need to make this bigger, our b value actually needs to be a fraction. It needs to be a half. That way, when we do pi divided by a half, we actually just get 2 pi. So our period is 2 pi, which gives us a b value of 1/2. And then phase shift. Again, we haven't really talked about phase shift much, and I'm not going to emphasize it a lot, but this has no phase shift. This, if we think about this in terms of a cotangent, because its leftmost asymptote is centered, is placed on this 0 location, has not been shifted at all, left or right. It's in its standard position, so there is none. And putting all of this together, I know it's fairly complex in what we've done. I'm not going to have you guys necessarily write the equations of these from the graphs, but I think that you can identify these features. Let's just try to write it anyway. So amplitude is 2. Tangent. Said the b value is a half, so 1/2 x. And then our midline was down at -4, -4. There we go. That's the equation. A was for amplitude, b multiplied directly with the x is for how our period changed. It was stretched out a little bit. We need that fractional value there of a half. And then midline, our graph was shifted down 4 units. So there we go. Again, I'm not necessarily going to ask you to come up with the equation of these, but I will ask you to sort of talk about the transformations that you do see. So looking at these and seeing the transformations is something that I will ask you to do. Okay, let's do one more of these here, and then we'll go ahead and stop. All right, tangent or cotangent. Again, pause it, think about it, see what you would answer. I'm going to go ahead and do so. For me, the clear answer is tangent, for, again, 2 reasons. One, the general increasing trend, right? Starts down low, goes up. So that's one way to leave me a tangent. But rightly, you could say, couldn't that just be negative cotangent? That would also be increasing because of the reflection. Yes, but no, that doesn't work really well here. And that's because of where my graph is centered. My graph is centered on that y-axis, that x equals 0 location. That's a nice default standard position for tangent. It doesn't, the leftmost asymptote isn't at 0. The center of my graph is at 0. The center of my cycle is there. That's leading me to tangent. So those 2 things together give me that idea. The next thing, let's go down and let's talk about the midline. Where's the midline? Well, we already sort of identified it, at least where it crosses our graph. It's right here. That's the midline. It's at 2, positive 2. What about the amplitude? How far above and how far below do we go? Well, this point is only 0.25 away, or 1/4 away. Same here. This point is only 1/4 away, or 0.25 away. So that amplitude is 1/4 or 0.25, whichever representation you prefer there. I'm gonna use the fraction, but you could use the decimal. There's not really a problem with that. Period. What is my period here? Well, we are starting our cycle at -pi/2, and we are ending our cycle at pi/2. What is the distance between those? We could subtract them. We could do, the end of our cycle minus the beginning of our cycle. Negative pi/2 minus a negative, that's the same thing as plus. I would just say our period here is pi. That's a standard period. Period of pi means that our b value is actually 1, because we're not stretching that graph horizontally or constricting it horizontally at all. Period is just standard, it's pi. And then phase shift. So again, we haven't really spoken a lot about phase shifts, so I don't think you should be surprised that there's actually none here. And that's because we are actually located in a nice central position for our tangent graph. It's centered over this axis. If it's not centered here and it's shifted somewhere, maybe over this way, this would be our phase shift, our C value. Where has that tangent moved? Has it moved to the right? Has it moved to the left? Where is that central location? Yeah, but in this case, there's none. It's nicely centered over the y-axis. And from that, we should be able to write our equation. Again, I'm not asking you to do it. But yeah, we're going to go ahead and do it. So this one would be y equals, this is tangent. So tangent Our amplitude was 1/4, so there should be a 1/4 here, or a 0.25. X, there was no B value or C value. No, well, it's 1, so we don't need to write that. And our no phase shift, so we don't have anything in there. And then just a +2 on the end. If you're trying to come up with these things and figure out what's going on with the equation, it's not a bad idea to just make a guess at the equation and plot it on Desmos. Like if you think this is your answer, plot it on Desmos and compare it to this. And I'll kind of show that process here in just a second. So I'm going to graph this one and just make sure we kind of understand what's going on with it. Let me clear this for now. Let's go back to Desmos and let's plot this graph. Okay, so it's hard to see, but it's centered there. Maybe we need to zoom in a bit, and maybe we need to change the scaling. Let's look back at that equation. So it had scaling by pi/4 and by 0.25. So let's change that scaling there. So on the x-axis, it's supposed to scale by pi/4, and then here is supposed to go by 0.25. Okay, that sort of worked. Oh, okay, here we go. Now we're starting to see things a little bit better. And, you know, some of the points aren't in there, but we're going from negative pi/2. You can kind of see the asymptote behavior here as we're zoomed in, and then a pi/2. So it's having those correct asymptotes. The midline is in the right place. These points look good. They look like they're right there. I mean, let's compare it again back to that. 1.75. Yeah, I mean, my scaling doesn't perfectly match what's going on there, but the graph does look good. Doesn't look like we've done anything wrong with that. So kind of compare, like make a guess at the equation, compare it to what you see on the picture, see if it matches things or something's off, and then make adjustments to your equation from there. Anyway, and you know, always remember you can change your scaling, you can zoom in, you can zoom out. If things aren't quite working for you, you might have to change the scaling to make it look a little better. But anyway, that equation looks like it works quite well to achieve this graph. All right, I'm gonna go ahead and stop right there, and I'll see you guys in class.